Let's start with permutation and combination. Now, this is one of those chapters which is most basic for mathematics, and we require, as we read the chapter probability and statistics, so in probability, this chapter is mostly covered. So what we are going to do in this revision of this chapter, we are going to just learn the important formulas, just revise them and apply them in the exams. So the first important formula in this case is NCR. How to calculate the value of NCR? NCR is calculated by n factorial by r factorial n minus r factorial. Let's see one example. 5C3 5 factorial divided by r factorial, that is 3 factorial, n minus r, that is 2 factorial. Now 5 factorial can be written as 5 into 4 into 3 into 2 into 1. 3 factorial can be written as 3 into 2 into 1. And 2 factorial can be written as 2 into 1. Now you can see that 3 into 2 into 1 cancels this thing. 2 into 1 cancels this thing by 2 times. So you have 10 is the answer. So in this way, we solve the NCR thing. Next formula is NPR, which implies n factorial divided by n minus r factorial. Or you can write r factorial into NCR. Fine. So this is something. Okay. This is called the combination thing. Combination of things. This is called the permutations of things. Permutations of different things. Fine. So this is the value of how many permutations you can make of r things, r different things from n objects. This is for r same things for n objects. How many combination you can are different things for n objects, how many different combinations you can form. So these are the two basic formulas, NCR and NPR. Now I'll move on to one condition, which is the famous formula that the number of permutations of n objects taken all at a time. You have n objects taken all at a time such that P are alike of one kind, P are alike of one kind, Q are alike of second kind, and R are alike of third kind. Fine, third kind. And remaining objects, which will be n minus p minus q minus r, are distinct. Distinct means different. Okay, so these are different. Then the number of permutations of n objects taken all at a time. How many number of permutations will be there? The formula is p. So first of all, n total objects are there upon p factorial of one kind, q factorial of another kind, and r factorial of third kind. Okay, one example for this. Let's say you have a chemistry book, physics books, and maths books. Fine. So three chemistry books, you have three identical chemistry books, then which are alike of one kind. Kind is chemistry. Then 4 of physics and 5 of maths. Fine. And you have total 13 books, or let's say 15 books. Fine. So remaining books are 3 books. 5, 4, 9, 3, 12. So 3 books are distinct. So how many permutations you can arrange them in is 15 factorial divided by 3 factorial, 4 factorial, and 5 factorial. So this is one of the most simple examples given in this. So let's move on to circular permutations, which is also one of the famous topics for JEE examiners. Circular, between JEE examiners, circular permutations. First of all, of n different things taken all at a time is n minus 1 factorial. Then without order preference clockwise or anti-clockwise is n minus 1 factorial by 2. Example can be given as the pearls of a necklace. Okay, they are arranged in a circle, let's say, and different things, and different things. Let's say all are different. So the number of permutations will be permutations of this, permutations of these pearls, such that we have a different necklace all the time. So taken all at a time, we are taking all of them at a time. So is equals to, let's say there we have 17. So this number of permutations will be 16 factorial. Fine. Because we keep one of them fixed and we move the other n minus 1 pearls, and we see the number of different permutations. Okay. So this is the formula for number of n different things taken all at a time, number of circular permutations. Now without order preference of clockwise and anti-clockwise is this half of just half of these. Why? Because if you can see the clockwise as the same as the anti-clockwise, then you are counting it twice. So you have to divide it by half to make the perfect answer. Number of circular permutations without order preference. Fine. This can be done when all these beads are same, right? So in that case, this will be the if all are same, then it will be only one thing. But like they are numbered from 1 to 10 and then again 10 to 1, then half are same, half are same. So in that case, clockwise and anti-clockwise law matter. Now we are going to see some important formulas connecting NCR and NCR plus 1, NCR minus 1, N plus 1 CR, all of that. So we are going to do that. First of the important formula is NCR is equals to NCN minus R, which I want you to remember in the exam, during the exam. These are important. You can apply them anywhere in the binomial theorem, in the mathematical induction they come sometimes, and of course in this permutation and combination, in probability also you can use them. So this is the thing you have to remember them. So first of all, how to prove this? NCR is n factorial by r factorial n minus r factorial. What is NCN minus r? N factorial by n minus r factorial and n minus r factorial. What is this? Again r factorial. So these two are same. Okay. So this you can remember that 5c3 is equals to 5c 5 minus 3, that is 2. Again 2c1 is equals to 2c 2 minus 1, 1. So this is nothing. You can say 2c0 is equals to 2c2. 2 minus 0 is 2. So 2c0 is 2c2 is equals to 1. nc0 is equals to ncn always, and it is equals to 1. One of the important properties. Second one is ncr plus 1 is equals to n plus 1c r plus 1. Fine. So 5c3 plus 5c4 is equals to 64, sorry. So you take the highest from here, and if you have two same here, then add 1 to this, you will get the answer. This is the way to remember this easy. The next property is NCR plus NCR minus 1 is equals to N plus 1 CR. Again the same property, just the way of representation is different. 5C4 plus 5C3 is equals to 6C4. Here R is 4. So you take the highest from the downwards, so 4, and add 1 to the upper one, because it is the same. Remember always this is the same thing, because they can give you 6C3 plus 5C4. In that case it will be different. Okay, so this is the thing. Now one of the important properties is NCX is equals to NCY. If this is given to you, then either X is equals to Y or X plus Y is equals to N, because this can be written as N minus R and this can be written as R. In that case X is not equals to Y, but X plus Y is equals to N. Okay, so this is one important property. Then we'll move on to the next one, which is NCR upon NCR minus 1. This is N minus R plus 1 upon R. This is used in binomial theorem because this is important one. And to calculate the rth term, to calculate the rth coefficient, this is the thing, right? Next property, NCR is equals to N by R, N minus 1 CR minus 1. This is also extensively used in binomial theorem. What do? We take this N and R outside. We have N by R. Then we subtract 1 from each other. Fine? So this is the thing, that N minus 1 CR minus 1. Next one is, another property is NC0 plus NC1, which we also read in binomial theorem. NC3 up to NCN is equals to 2 to the power n. This is one of the important formula to remember. 4 times question has been asked in 4 adjacent years, and from this only. So you've got to remember this before the exam. Again, NC0 plus NC2 plus NC4 plus is equals to NC1 plus NC3 plus NC5 plus, and both are same, and R equals to 2 to the power n minus 1. Because when you add them, you will get NC0 plus NC1 plus NC2 plus NC3 plus NC4 plus NC5 plus up to them NCN, and which is equals to 2 to the power n. So half of this series will be equals to 2 to the power n by 2, that is 2 to the power n minus 1. Fine, this 2 to the power 1, so 2 to the power n minus 1. Now here we complete our permutation and combination. We have left many formulas because they are not that much important, but whatever I have discussed, if you keep this in mind, this much in mind, then with the help of probability formulas and this much, you will get to solve each problem of probability also and permutation and combination. So all the best.